Algebra 1, Lesson 19 and 20. This is going to be a pretty quick video about solving one-step equations by adding and subtracting, and then Lesson 20 is about graphing on a coordinate plane. So, when we look at our equations, we often see ones like these, okay, where we have a variable, an equal sign, and then something done to that variable. Well, when we are talking about a variable being added to or subtracted from, we need to do the opposite in order to get x alone. Our goal here is to get our variable on its own side so we can say that variable is equal to a certain number. Well, in order to do that, if I have x plus 6 equals 4, well then I need to do the opposite of adding 6. Well, if we think about the operations, adding and subtracting are opposite from each other, so I would need to subtract 6 from each side. Well, if I take 4 minus 6, that would equal -2, and if I have added 6 and subtracted 6, those go away and I just have x. In order to check to make sure that our answer is correct, I can always plug our number back in our original equation and say -2 plus 6 equals 4, and that is correct. So whenever we see something done to our variable, I need to do the opposite. So x plus 8 equals 3, I would subtract 8. And we would have x equals -5. 5 equals d plus 1, I subtract 1. And I get d equals 4. When I get down to c plus -4 equals -5, I'm going to rewrite this because I have c plus and -4. That's the same as c minus 4 equals -5. Well, if I'm subtracting a 4, I'm going to add 4 to undo that. So I get c is equal to -1. Going on to the other side, subtracting 7 from x, I'm going to add 7. And I get x is equal to 2. Okay, you can do the next two on your own. But if you want, the other way to check and to logically think about these is if I said, like with number 2, I have a number plus 8 and that's going to equal 3, well that number would have to be -5 in order to add 8 to it and get a +3. So think about them logically if you want to make sure that your answer is correct. Okay. To continue on with this lesson, let's try some of these fraction ones. And if I have x plus 1/4, I need to subtract 1/4 on each side. But if we see, we don't have common denominator, so I need to take my -3/8 plus my -1/4, and I need to get common denominators. So I'm going to multiply this one by 2/2 to get a denominator of 8, so that I have -3/8 plus -2/8, and I have a -5/8. That equals x. I could do the same with x plus 1/2 equals 3/4. I'll give myself a little bit of space, and we subtract 1/2, but I have to get common denominators. That's the same as 2/4, which means that 1/4 is my answer for x. So we can do it with fractions, we can do it with whole numbers, whatever we have. Okay? Subtracting a number, we add 12, we add 5, we add 30, we add 14. Whatever we do to one side, we do to the other. Let's try the second one down here. The temperature in Lubbock, Texas rose 16 degrees in 1 week to 97 degrees. At what temperature did the week begin? Well, we need to write and solve an equation for this. So if we know we had a certain amount of degrees and we added 16, we rose 16 degrees, and that got us to a temperature of 97, well, we could write an equation like that. And to solve it, we would subtract 16 from each side to see that we started the week at 81 degrees. Okay? So these are my one-step equations with adding and subtracting. You can see some extra practice problems here for you to try out. And let's go on to our second lesson, lesson 20, graphing on a coordinate plane. So if we look at our coordinate plane, so first we put that big cross in the middle, label the x and y axes. All right, so our horizontal is our x-axis, our vertical is our y-axis. Label the quadrants. Well, my first quadrant is always my positive, positive, positive x, positive y, which is this one right here. And we do these with Roman numerals. Once we have my first quadrant, I go counterclockwise to say the other ones. So this is my second, my third, and my fourth. Okay, and if we are asked to graph 4, 2, well, remember that my x comes first and then my y. So I'm going to go 4 on the x-axis and up 2 on the y-axis. Or if we have -3, 0, I have -3 for x and nothing for y. Okay? So we have independent and dependent variables. Independent is the value that can be chosen. It's the input value. In our thinking about our coordinate grid, we are talking about our x value. A lot of times we'll see a table of values with x and y, and we normally choose the x, maybe -1, 0, 1, 2, and so on. We rarely choose the y to find x. We choose x. That's our independent. Our dependent variable depends on what we choose for our independent. So the value is determined by the input. This is also called the output variable. And with our coordinate grid, we're talking about y. So if we have these different situations, number of traffic violations and cost of car insurance, which one is independent, which one is dependent? Well, the number of traffic violations, does that depend on your cost of car insurance, or does your cost of car insurance depend on how many traffic violations you've had? And you will say, of course, the cost of car insurance depends on how many traffic violations we've had. All right? Electric bill and kilowatts of electricity used. Does my electric bill depend on the amount of electricity used, or does my electricity used depend on how much I have for my electric bill? Well, you would say, of course, my electric bill depends on how much I have used. So we would label those dependent for bill, independent for electricity used. Okay, distance traveled and amount of gas used. Does my distance traveled depend on how much gas I have used, or does the amount of gas that I've used depend on the distance traveled? And you'll say, of course, the amount of gas used depends on the distance traveled. Lastly, water bill and gallons of water used. This is very similar to the electric bill. Water bill is my dependent because it depends on how many gallons of water I have used. All right, moving right along, let's look at some situations like this one. We have an equation, y equals 4x plus 2, and we are asked to complete the table and graph the equation based on the points. So we plug in these numbers. We plug in our inputs, our independent variables, into our equation so that we have y equals 4 times -2 plus 2. Well, that's -8 plus 2, which is -6. We do it again for 0. Y equals 4 times 0 plus 2. So we just get 2. Y equals 4 times 2 plus 2. Well, that's 10. And y equals 4 times 3/4 plus 2, which 4 times 3/4 is 3 plus 2 is 5. So we go to graph these. X is -2, y is -6. And 0 for x, up 2 for y. 2 over for x, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 for y, way up there. And lastly, 3/4 and 5. We go 3/4 over on my x and up 1, 2, 3, 4, 5, staying that 3/4 on my x. And I connect my big dots. And I have my line. So here's the deal. With any type of function that we have, if you are able to complete a function table for it, choosing x values and solving for y, you can plot any function. Okay? Just think about that when you get stuck and just create a table. That's always a good fallback. So the federal minimum wage is about $7.25 per hour. Total minimum wage is dependent on the number of hours worked. So we can choose for 1, 3, 5, and 8 hours, what is the pay? Well, just like we did on the other page, you would make an XY table, and I'll let you do that yourself, but you will see that it starts at the origin at 0, 0 and goes up at $7.25 per hour. And it doesn't make sense to go into the negatives, because how could I have negative hours work? Over here, we would have negative hours work and negative pay. So in this case, it wouldn't really make sense to extend that line to that left side. So just plug in those numbers and find the amount of pay. Lastly, the prom committee raises money for the prom by selling flowers. The money earned for the prom is dependent on the number of flowers sold. Money is earned represented by the equation y equals 3x minus 75. Make a graph to represent the equation that would be an appropriate scale. So if we start plugging in our numbers, x and y, we would see that if we started with something like 0 for x, they sold 0 flowers, we plug it in and we see we get a negative 75 for our y. Maybe we plug in that we got 5 flowers sold. Then we would say, all right, 15 minus 75 is a negative 60. We keep going, maybe 10. Okay, 30 minus 75 is negative 45. And we keep going on. Well, as you can see, we're still in the negatives. We haven't earned any money yet, so maybe we need to go bigger numbers. Maybe we ended up selling, let's say, 25 flowers. Well, 25 times 3 is 75, so we finally broke even. Okay, we're finally out of our scale. So if we think about our scale, maybe we need to go up by 10 or 20 on each notch. Think about that as you graph your equation. Okay, and you'll definitely need to go maybe even to 100 flowers sold to be able to see some good numbers, going 25, 30, 35, 40, all the way up to maybe 100. Or you could do 25, 35, 45, 55, and so on. All right, make a table of this, show it on a graph, but of course you're not going to show all the way 0 to negative 75 and 0 to positive 75. Go by a scale of maybe 10s or 20s. Well, I hope this was helpful for homework and for studying.